let's start with the part 3 of chapter 1, light. In this video we are going to discuss about nature of image. So what is the nature of image formed? Whenever an image is formed, what will be that image's nature, right? Let's see. Any image that is formed can either be real or virtual. Okay, whatever image is being formed, it will either be real or it will be virtual. So there are two type so these are the two types of which nature can an image have. Okay, so what are the nature of image? Either real or virtual. So when does an image is real and when is an image virtual? Let's try to understand this. When is it going to happen that whatever image you have formed will be real, or when your image will be virtual? Let's try to understand this with an example. Let me see. I've put a mirror here. I've put a mirror here. M dash, right? So now if this is my object, okay, this is my object which is giving me light. Let me say that right here, this object is giving me light like this. Okay, so this is the point, this is the rays which are striking my mirror, and then these rays are getting reflected back. Okay, these rays are getting reflected back. Now let me try to produce these rays backward. Okay, I've produced it, and I see these intersect. I've produced backward like this and like this, and I found a point where these both of these rays when produced backward intersect this point. This is the point where my image will be formed, and this image is actually virtual. Now let me try to explain to you what when an image that is formed is said to be real, and when an image that is formed is said to be virtual. Okay, we say that an image is real when rays of light actually intersect after reflection. Whenever the rays of light after reflection intersect, then we say that a real image is formed. But if the rays of light after reflection do not intersect, then we say that a virtual image is formed. This kind of image, or in this kind of situation, these rays you will find that will always intersect when you produce them backwards. Let me try to explain it one more time. See, this was my object, right? This was my object. My object, did my rays after reflection actually intersect? Did they intersect? No, they didn't intersect, right? They intersected when I produced them backward. So this is the very definition of a virtual image. In a virtual image, the rays of light after reflection do not intersect, but they will intersect if you produce them backward. So that means that this image is basically what? A virtual image. Now if my images would have intersect right here, then I would have said that they were the real images. For example, if this is my mirror, right, and now I've got a ray of light from this from something, from some source, and from here as well I'm getting a ray of light, and then my these ray of light are basically reflecting back, right? So did I find this point where my after reflection my rays are getting intersected, right? So this image is probably a real image. So now you understand. See, in this situation, my rays of light, these rays of light after reflection actually intersect. So that means if they are intersecting after reflection, so the image that they will form will be real. So this is an example of a real image, and this is an example of a virtual image. So I hope now you are very clear about real and inverted image, right? Let's try to understand. Now we will discuss about reflection. But now we are going to reflection through plane mirror. Okay, through plane mirror, not by a plane surface, but by through a plane mirror. Let's try to think about it. See, this is my plane mirror m dash. I'm going to derive some characteristics as well of plane mirror. Basically, it's very important to discuss when an image is being formed by a plane mirror. A plane mirror is a mirror that is found in your home. homes, right? We have it in our homes as well. So whenever an image is formed in it, what kind of image is produced, what are the characteristics that that image possesses? We will discuss them, but first let's try to understand how reflection actually occurs in that kind of mirror. See, I've put a mirror m dash right here. This is my mirror. Okay, this is my mirror m dash right here. Now I've put an object of height h right here. This is in front of the mirror. I've got an object of height h. My this object at point b is going to produce some light, and that light is going to basically be it is providing some ray of light, and this ray of light is going to strike the mirror at this point c. See, if it is striking the mirror at this point c, can I now I need to draw the normal. When I say that whenever a ray of light whenever an incident ray strikes the mirror at that point at which it strikes, we need to form a normal, right? But normal that I'm going to form is basically this perpendicular line, and when I try to find the make draw a normal, I find that my incident and normal are actually the same, one and the same line. That means they are actually parallel. That means there is no distance between them. This is my incident as well as my normal ray. That means the value of angle of incident is basically 0, right? So in that case, what happened is that ray will be traced back towards its path. So that is the reason why first it is striking and then it is getting reflected back at the same time as well in its and it is traced back to its original the previous path, right? So now same thing happens from this point as well. At point A, again my ray is incident at point O, and again I will find that angle of incidence value is 0, so it will again trace back it path. So it again moves back to from where it came. It is reflected backwards, and okay. So now, but from point P, a ray of light actually strikes at point O as well. So what happened is that there are three rays of light. First, a ray of light goes from B and strikes the mirror at this direction. Then a ray of light from point A strikes the mirror at this direction. Now from point B, again a ray of light strikes, but this time it strikes at some angle at point O. So after at point O, this ray of light is again reflected backwards, and now I draw AO, my normal. So obviously this angle which incidence and normal is going to make is angle of incident, and this angle is my angle of reflection, right? Now what I do is that all of the reflected rays, I try to trace them backward. I try to produce them backwards. I will produce all of the reflected rays backward. So this I've produced backward, this reflected ray. Again I produce this reflected ray backwards, and this reflected ray backward as well. And I will find that both of these reflected ray are going to intersect at this point. Then what I do is that join this point as well, and I will find that I have got at this point I've got an image of my object. This is my image which I've got image, and I find that I write it as a dash b dash, because this is my image. This is the object ab, and this is the image of that object a dash b dash, which I have found that is formed here. See, from this I say that it has height h dash. Then I observe, isn't it quite clear that this h is basically equal to h dash? And right here u and v are the object and the image distance. That is this u is the distance between the object and the mirror, and this v is the distance between the image and the mirror. So u and v. Also now I have also found that this u is basically equal to v as well. So let's try to conclude the points that we have got. There are actually 4 points that we have got. Okay, the first thing that I've got is that that size of image is basically equal to size of object. So size of image equal to object, right? So my size of image is equal to object. According to this, I've concluded. See, h is equals to h dash. It's clear, right? Then again another point is that my object distance is equal to my image distance. That means whenever an image is being formed by a plane mirror, the image formed and the mirror the distance between image formed and the mirror is going to be equal to the distance between the object and the mirror. So I can write it as object distance equals to image distance. Okay. Okay, and another thing, the image that is formed, okay, the image that is formed is going to be laterally inverted. You will find that the image that is formed is laterally inverted. What does it mean? Whenever you look at your image in front of the mirror, you will find that your right side will be portrayed as left and your left side will be portrayed as right. So this is what means by laterally inverted. Okay. And what is the fourth last point? Obviously the image, see the image, is it inverted? Have you got an inverted or an inverted image that is formed? No, no. What is the image? Image is erect. And did the rays actually intersect after reflection? Did all of these reflected rays intersect after reflection? They did, or they didn't? No, they didn't, right? So that means these rays did intersect, but when they were produced backward. So what is this image? This is a virtual image, virtual and erect. So these are the four main points through which we can define. So these are the four main points, or these are the characteristics of an image which are formed by plane mirror. Image size is going to be equal to object size. Image distance equals to object distance. Image will be laterally inverted and image formed will be virtual and erect. This right here I've written that angle I means angle of incidence, angle R means angle of reflection. So this concludes our part of nature of image and obviously also about characteristics.